Hello, good evening to everyone. Welcome to Unacademy, which is the biggest online education platform in India for GATE, Computer Science and IT. In this session, I'm going to show you how to construct the Turing machine. In the previous class, I've shown you one problem, how to construct a machine. In this session, we'll be discussing more about the construction of Turing machine and understanding of Turing machine. Okay. If you're watching this video, guys, please like this session very quickly. And let me begin with myself, Mallisham Devasane. You can call me as Deva sir. I have secured all rank 119 and 210 in my PTech and studied MTech from IIT Bombay. I have 12 years of teaching experience so far now, and TOC, compiler, programming. These are the subjects that I take on this platform YouTube channel. And my referral code is DEVALIVE. DEVALIVE. To get 10% discount, also if you need any guidance from me, you can. So this is the advantage of DEVALIVE. And this is my profile on Unacademy. Please visit this profile www.unacademy.com/@DevaGateCSE, and please follow me so you may get daily notifications of my classes. So these are the various free classes that I have already taken more than 300 hours on Unacademy. Please watch all these free classes from C, TOC, CD and Algo subjects. If you want to know about the plus benefits, you can, that is, you have live lectures and live test, crash courses, practice questions, rank improvement batches, doubt solving sessions, and even revision batches, right? Previous year questions. So many benefits from the plus subscription. And you also have now iconic subscription, which will have more advantages than plus. Like you will have a personal guide to monitor your performance and to discuss with you. You will have a study planner and expert guidelines. This is the difference between the subscription plan for plus and iconic. 22,500 for plus after applying the code DEVALIVE for 1 year. Similarly, iconic 1 year plan has 40,500 after applying the code DEVALIVE. Okay, these are the subscription plans for iconic and plus. You can go for credit, debit or net banking. Use DEVALIVE while making the payment. And please join this Facebook group to get regular notifications from us. So whenever we upload any schedule, you will be knowing there. And this is another one, which is Telegram channel. Here we daily upload our material, and also we will notify. We'll send some of the schedules so that you will get notifications. Yeah. Good evening. Now these are the various free YouTube channels we have on Unacademy, from Unacademy. So please share with your friends. Right? We have nearly 9 channels we have. 10 channels we have. Please refer to your friends so they may join our sessions to learn something from us. Yeah. So if you are watching this video, please share and also like the session and subscribe. And if you have any doubts, okay, Virat, good evening. Akash Bharadwaj. This is not the time for uncountable and decidability. Both are different words. If you want to learn about them, wait till undecidability. Right now I cannot speak about decidability, uncountable in this class. This class is about construction. When I come to undecidability, I will talk about everything. If you want to know about the difference, please go and watch my free classes on Unacademy. Already I have taken both the sessions. More than 3 times I have taken difference between uncountable and countable, as well as decidable and undecidable, and all these 4 words, what is the difference. Okay, so in this session I'm going to talk about the construction of Turing machine for another problem. And guys, yesterday I have designed a problem that is we have already designed. Now let's move to the another part of the construction for different problems. Okay, let's focus on the another problem now. This is the second problem. Okay, now how to design the Turing machine to accept this language. Guys, if you look at this problem, we have epsilon, but remaining all strings will have ABC definitely. Right? We have A power 3, B power 3, C power 3 and so on. Now you require to understand, if I have, let's say, 4 A's, 4 B's, 4 C's, and you need to make an approach, how do you want to accept this input? Your head points to the first A. Now if you remember the previous problem, which is exactly same as the previous one, but additionally the C is there, so you need to go further after replacing B with Y. So what is our concept, guys, here? Here we replace A with X and somehow we'll replace this B with Y and somehow we'll replace this C with Z. And we'll come back, we will do the same thing for another A. Right? Yeah, next we will do for this A and this B and the second C. So similarly we'll get X, Y and Z. Yeah, and finally we will do this A and B, C. Now how to understand this problem now? We understood the approach. Okay, every A, B, C in one scan we can match, so we can replace with X, Y, Z respectively. So how to make a machine to accept this string and what is the acceptance condition for this problem? Before designing the machine, let me help you to understand all the functions. Okay, we have Q naught. We have Q naught to replace A with X. And then what is the Q1 job? To find out the B and replace with Y. And additionally it has job that script A comma Y, because in future the Y is also there before the small base. Then what Q1 does, it will give to Q2, but this time it will not left, now it is right. Q2, it has to find the first C. Yes, Q2 what it does, replaces C with Z. It means this C with Z. To do that, first you need to ignore skip B and Z. If you skip them, you can reach the C, otherwise you cannot. Now after that, it will take left turn, then Q3 is going to skip all of them to reach this first X. Q3, it is going to skip B, Y, A, and also initially Z. Z, B, Y, A. If you skip them, you can see the A, so that you can see the X, so that you can take right turn. You can take a right turn immediately. So here Q3 job is to do the reverse scan. Because what is the Q3 job? Q3 job is to do the reverse scan. Okay, now let's focus on this machine. How to design a machine. Now I'm assuming some intermediate step, guys. 6 A's, 6 B's, and then 6 C's. So if I am starting from here, Q0, it replace A with X and give to Q1. What Q1 job? To find out the first B. Then it has to skip A and Y. So Q1 has to skip A and Y, and Q1 will replace B with, let's say, Y, and Q1 goes to Q2. What Q2 job? To find out the Z. Now here you need to skip B comma Z, right? So when Q2 sees the Z, sorry, what I am saying, Q1 will change to the Q2. What is Q2 job? To find the C. That it has to skip B and G. Now Q2, when it sees C, replaces Z and takes left turn. Let's say Q3. What is the Q3 job? To reach the first X, so that it can hand over to Q0. To reach that, it has to skip Z's, B's, Y's, A's. Right, guys? So this is our difficulty of this problem. So let me design the machine. When it sees A, it will replace with X and take right. But Q1 job is to skip every A. And skip every Y, so that you can take right move, right move, right move, as long as A's and Y's are there. When it sees the B, replace with Y and take right only. You can also take left, but how do you know the string is valid? Okay. Now, what is Q2 job? If it is only A power, B power, just you can take left. But now, C also there. Now only if you go to C, you can understand how many C's are there. So skip all the B's, skip all the Z's, and you will reach C. And doesn't matter what is there in the, what is there in the tape at the end. So you can write whatever you like it. So I'm taking left. What is a Q3 job? You skip everything that you see in the reverse scan before capital X. Before capital X, who is there, guys? Z is there. And then B's and Y's, also A's. If you skip this one in the left direction, you can reach capital X. When you reach capital X, your job is only one thing: replace the X and take right. So Q0 will start from the next A. Yeah. So now Q0, if it sees the blank, it can't see the blank. If it sees the Y, because Q naught can see the y if you do sometime. When Q naught sees y, that means all the x are over. What you do? Stay somewhere to skip all the y's, and whenever it sees blank, because blank is there at the end, then do whatever but go to final. Everyone? So this is the Turing motion, a second problem that we have designed for A power, B power, C power, and their powers are same here. Okay. So now, guys, we have understood two problems so far. And did you understand epsilon? If you want to understand epsilon here, from Q naught, it may see the blank directly. It may see the blank, because epsilon you want to accept, then blank should be taken. What we have solved, now what I want to understand from here, suppose I have A star, B star. What will be the Turing motion? It's already regular, right? If the language is regular, very easy to design Turing motion because both configurations matches. Let's look at how to design finite automata. You will have A's, this will make A star, B star. With A's, we can take self loop. Without A's also directly we can go to the second state. Okay, so A star, B star is regular. Now what is the construction of Turing motion? Anyone, guys? Copy paste old motion. Copy paste old motion. Guys, we can copy paste old motion, but don't keep the finals. What we do on finals, we have a special final here, blank and nothing. Here also blank, you can do nothing. Why? Because those two are coming on epsilon, on B come to the final, because capital A should accept the string, capital B should accept the string. To accept them, we are making a logic using intermediate representation, or using what I can say, using blank. So on blank I am going to final, indirectly that state is also final. Everyone, on blank I am going to final, it means that state is also final, like epsilon move in the PDA, right? DPD or whatever you have. So any regular construct, any regular language we can construct Turing motion. And it means I can convert any finite automata to Turing motion. This conversion is possible. Yeah. Is it clear, guys? Any parameter you can convert to Turing motion. But so far I have not given Turing motion So first time, let me give some Turing machine. How do you understand? Okay. Yeah, you have to read as a symbol. Now I have Turing machine. What is the language? What is the language accepted by this Turing machine? Right? So how do you understand this problem? In a final state, we always keep a special because then only at the end of the analysis of our input will come to final. Okay. The language is, anyone? Language is, you can accept epsilon or you can accept 1a and you can accept AA because only you are moving right. No, sorry, what I did here. You need to represent with three parameters now. So AAR, AAR, PBR. So in final tutor we do A comma B, but here we don't do it. Yeah. So this is what I want. AAR, BBR means I'm reading A, I'm writing with A, I'm moving right. So without three parameters, very difficult, guys. Okay. So I want you to understand this way. And what is the language accepted by this? Anyone, guys? Even you can accept 1B here. Its language starts with A. Language starts with A. Because after 1A, you can accept any string, you can understand any string by going to the final in one path, like this path. This path, all the string starts with A, but one string which is not starting with A, even it is epsilon, that is accepted in another path. So this path is epsilon, this path for A star. Starts with A. Starts with A. Okay, because starting is compulsory. Right? So let's focus on every string that you have. If you want to understand epsilon, but epsilon is not there, so who will be there on the tape? B will be there. So if B is there, directly we will go to final. Let's say Q0, QF, and Q1. So you will out at QF. You read a B and you will go to QF. Okay, so epsilon is accepted. Clear? Okay, so guys, I have given a few examples. Now I will give more examples to understand. What is the machine? Which language accepted only epsilon? What is the language accepted? A star. If you don't want A, by just reading a B, you can go to final. You can look at how I'm designing the machines for different languages. Okay, but this kind of machines we don't have. This kind of machines where we have infinite automata. So what we write always something like this. So focus on what I am going to do here. Yeah. Now what is the language? What is the language accepted by this machine? Anybody guys? It's just like a finite automata concept. We have A star, B star. This strings nothing but A star, B plus strings can reach final. Remaining strings will not have a path, so they will crash a Turing machine. It means they are not accepted. Everyone guys? Now look at this problem guys. We have a Turing machine. Whether A comes or B comes, it doesn't matter. It's just moving right direction. So whether you write or not, it is just equal to this machine guys. It is just equal to this machine. You are doing not anything but you are going right. You can write with any symbol but go right. Then this is also same as the above machine. In above, first machine is going to read A and writing with B, and second machine reading A definitely, but I am not going to write because I want to understand what I am reading. Okay, so both will do the same job. So I am keeping the whole circle. Both will do the same job. Anyone? So has to read as a symbol. What is so? Okay. Now, are they both doing same job? Anyone guys? A star, B is there. That's all. A star B. Because B definitely should come to reach final. Before B, any number of A's also accepted. But what you write, it's not going to be bothered because we are not looking at a tape after accepting. Okay. So now let's go to the 9th problem. This is the different machine. This machine is for halting purpose only. Everyone, there is no kind of acceptance, there is no kind of rejectance here. Only halts or not. So which strings it is going to halt? Which strings remaining assume they never halt. So which strings are going to be mentioned here? Remaining are not mentioned, but they are also halt. Here A star strings have a path. That makes the A star strings are going to be halted on this machine. That makes this machine is clearly represented for A star. But other than A star, we have not mentioned. So we don't know what's going to happen other than A star. Is it necessary to give a state for epsilon? Yeah, because we have the blanks now. Our assumption is blanks are there on the tape. So without reading the blank, we don't decide here. So we have a different Turing machine here. We have a different Turing machine. Yeah, in our machines, it is must on epsilon also you need to read the blank. Okay. And other than A star, what we are not talking about, other than A star, we are not interested at all because we have not defined any path. Okay. Yeah. So blank, we have at the end of the input, we have the blank at the end of the input. Fine. So keep doing it. So now what this machine does, this machine is about halting, it's not about accepting. So what do? Now we have this path, definitely on epsilon it halts, on epsilon it halts, and this path we will come to every state to halt. If you want to halt, you must come here. You must come here. If you want to come here, then definitely you should take the path A, then small b. Alright, AB is the beginning of that whatever you read. So it looks like L is equal to epsilon if you go to alt directly, other side AB, B star. Clear? B star. This is the language you are going to get. Okay, so please guys today practice it. I have some problem in teaching today. Tomorrow I'll come up with more problems about Turing machine, but please guys, these 10 problems you practice, understand them. Tomorrow I'll discuss many problems in the construction of Turing machine, even understanding Turing machine. So please attend. If any of the class that you have free time, if I am taking this duration, please attend my classes. This is my profile where I am not able to take today much time, but still I'll come up with more examples in the next class. And this is my profile link. Please go and watch videos and also use DEVALIVE code if you want to take a subscription. Yeah, is this AB plus? Yeah, AB plus, correct. Fine. So also watch other classes from our educators on this channel, and thank you so much. If you are learning something from me, please like the session, and also share with your friends and subscribe if you have not yet done. Thank you so much. The small session today I have taken because there is some ice problem today.